Good morning. This is Mrs. Tellas. We're going to do 8.4, section 8.4 today. We'll be talking about vertex form of quadratic equations. And right here is your vertex form that you want to write down. That nice long formula. So for the last 2 weeks, we've been graphing quadratics as well. We have been using standard form. Okay, so this would be section 8.3 right there, standard form with the bx included, using x equals negative b over 2a to find the vertex and the x's of symmetry. The day before that, we did section 8.2, y equals ax squared plus c, where our vertex was 0, c, whatever the c was. It was that parabola was moving up and down the y-axis. And then the very first section was y equals ax squared, where our vertexes were all 0, 0. And this a was either shrinking it, if it was between -1 and 1, or stretching it, making it more narrow, if it was bigger than 1 or smaller than -1. So in all of the vertexes where there's no b and c are 0, 0. So now we're going to switch to this equation instead for quadratics. So we're going to start with a portion of it and then work our way up to full formula. So remember, f of x is the same as y. You're going to want to write this down. All right, so we're looking for this h right here. Notice in the formula that's minus h, okay? So h is what we're looking for. That h is going to tell us a bunch of stuff. It's going to tell us what the vertex is. So whatever that h is going to go in for x in the vertex. And it's also going to go in for our x symmetry, x equals h. Okay? If h is a positive number, that's going to shift it or horizontally translate the parabola however many units to the left. And if h is negative, it's going to shift it or horizontally translate it however many units to the right. All right, so let's do this first one. So we can tell, based on what we know about standard form, we can tell that a is 1/2 and h is 4. And it doesn't have a k, so k is 0. Okay, so this is my h right here. So h is 4. We can tell that it's a smile, or it opens up because it's got a positive a. And we can tell that it's also a shrink, or it's going to be wider than the parent function because 1/2 is between -1 and 1. All right, so my formula or my vertex is 4, 0. And my axis of symmetry is x equals 4. So I can go ahead and graph that. 1, 2, 3, 4. So now I can make my table. So 4, 0 can go in the center. I went up one and up another to get the right side, and back one and back another to get the left side. So since it's symmetrical, these two y's will match, and these two y's will match. So let's go ahead and stick the 5 and 6 in. That'll keep it positive. So we're taking these x values and putting them in right here for x. So 1/2 times 5 minus 4 squared. And you can take your calculator and type that in, completely up to you. Use your parenthesis keys and your squared button. You're going to get 1/2 here. And that makes the 3 also 1/2. Then if you put 6 in there, again, feel free to use your calculator. You're going to get 2. So if we go over here and graph it, 5 1/2 and 3 1/2 and then 6 2 and 2 2. So there is my picture. Notice that it is wider like we expected, and it's a horizontal shift to the right 4 from the parent function. Okay, domain is all real numbers. Because I could have picked any number to put in for x, I just had a strategy with these. And then y, it's opening up, so greater than equal to the lowest point on the graph, where the minimum is right here, 0. So 0 is the number for the range. All right, number 2, same thing. It's got an a of 2. It's got an h of -5, and k, since there isn't one, would be 0. So since a is 2, this is a stretch, which means it's going to be more narrow. And I know h is -5 because the formula has got a minus in it. And since that has a plus in it, the only way to be a plus would it did minus -5, which would make it a plus. Okay, so my vertex is -5, 0. And my axis of symmetry is x equals -5. I could tell with the +5 that this was going to be a horizontal shift left 5. So I'm going over 5. 1, 2, 3, 4, 5. Okay, now I'm going to make my table. I also know this is a stretch because of the 2 for A. And the stretch is more narrow. So if I put my -5, 0 here, so up 1 would be -4, up another -3, back 1, and back another. So now we're plugging these x values in here for x. So y equals 2 times -4 plus 5 squared. So that would be, let's see, that's 1 squared is 2, so that'd be 2. Okay, and if we do the same thing for -3, that's 2 squared, looks like that's 8. I can tell this is a smile because 2 is positive. So let's graph this. -4, 2, and -3, 8. And it's symmetrical, so it's kind of easy to graph the other side. Whoa, I missed almost all those points. That's okay. So there's my parabola. Maybe I could shift it over a little. Let's see. Oh, yeah, that's a little bit better. Okay, my domain is all real numbers. And my range is y is greater than or equal to, because it's opening up. The lowest point, or the minimum, on the parabola is 0. So that's the number in the range. Okay, and this is a stretch because of that 2. A stretch factor of 2. All right, I would like you to push pause and give this a try. I want you to tell me what h is, what the vertex is, what the axis of symmetry is, make a table, and draw the picture. Also the domain and range if you haven't done that already. Okay, so got a 2 for h. So that fills down real easily once I get that 2 down for h. I can tell by looking at it that we're going to shift it 2 to the right, or a horizontal translation to right. I can also tell from this negative in the very front that it is going to open downward. But it's going to be the parent function just open downward and starting 2 to the right. So it's going to start right here. Okay, so I can predict, because I know it's the parent function, I'm going to go over 1, down 1, over 1, down 1, and over 2, down 4. Over 2, down 4. So I'm predicting that it looks like this just because I know about the parent function. Let's put the points in and see if we're right. So 2, 0, up 1, up another, back 1, back another. All right, let's stick these numbers in here. Let's go with the high side because that'll make this positive on the inside. So -3 minus 2 squared. That's 1 squared, so that's -1. And again, feel free to put that in your calculator. Well, let's do the 4. So 2 squared is 4, so that's -4. And that's exactly what's graphed here. So we already have it graphed, just because we knew about what the parent function looks like. So domain is all real numbers. And the range is y is less than or equal to. Less than or equal to because it opens down. And the highest point, or the maximum on the graph, is the 0 area. So 0 goes there. All right, so this is the second part. Now I have the whole formula in there. So I have f of x, or y. And this is the part we stopped at before, and I'm going to add the k in there. So the h is my horizontal shift, my sideways shift, and this k is going to be my vertical shift, up or down. Okay? All right, so the vertex is h comma k. They come straight from the formula. And my axis of symmetry will still be x equals h, whatever that is. All right, so here we go. Compared to the parent function, I can tell that this opens down because it's got a negative here. I can tell that the 2 makes it a stretch, so it's going to be more narrow than the parent function. H is -2, and I'll write that down. H is -2. So that means it's going to shift 2 to the left, or a horizontal translation of 2 to the left. And K is 3. So I can tell that is a vertical translation of up 3. So my vertex is -2, 3. So -2, 1, 2, 3. That's where it's going to start. I know it's opening down. Okay, so if I make a mistake, if I get a point up here, I know something's wrong because this is the highest point on the graph. It's the maximum. So I don't know what the points are because it's not the parent function exactly because of this 2. So let's stick -2, 3 in here. Up 1, up another, back 1, back another. And we will stick this in here into the formula. And then we're going to use our calculator. So -2 times -1 plus 2 squared plus 3. So I'm going to stick this in my calculator. So -2 parenthesis, -1 plus 2 parenthesis squared plus 3. That gives me 1, which means these are both 1. And then if I scroll back and in its place put 0 instead of -1 or -4 instead of -1, that gives me -5. So graphing it, it should be opening down. So -1, 1, -3, 1, -0, 5, and -4, -5. So it looks like this, which is kind of what I was expecting. So the domain is all real numbers, and the range is y is less than or equal to, because it's opening down. This is the red dot is the maximum, and that's at +3. So 3 goes in the range. All right, I want you to pause it. I want you to tell me about how it compares to the parent function, what the shifts are. Is it a shrink or a shift? Does it open up or down based on what you see? Come up with the vertex, the axis of symmetry, and then make the table and graph it and see what you come up with. Okay, I can tell because of this 3. First of all, it opens up like a smile, and the 3 makes it a stretch or more narrow than the parent function. I can tell that H is +1. I'm going to write that down. H equals 1. And K is +6. So my vertex is 1, 6, and my line of symmetry is x equals 1. So 1, 6. All right, now let's make our table because I don't know what the points are because it is a stretch of the parent function. So 1, 6 is going right in the middle. All right, let's plug 2 in. So 3 times the quantity, 2 minus 1 squared plus 6. And again, I'm going to use my calculator. 3 parenthesis, 2 minus 1 parenthesis squared plus 6 is 9. So these are both 9. These match. And if I do the exact same thing, this time with 3 instead of 2, that comes up as 18. And 18 is off my graph. I'm going to estimate. I'm going to have to. Okay, so 2, 9, right 2 and up 9. Right on the 0, up 9. And then right 3 and up 18. I'm going to put it way up here. And write 1 and +18. So this is my parabola. Ooh, having trouble drawing that with my slate. The domain is all real numbers. And the range is y is greater than or equal to because it opens up. This is the lowest point on the graph, so 6 is part of the range. I hope you got that right. If you did, give yourself a pat on the back. Good job. Hey, if there's anything you're missing, hopefully you figured out what went wrong. Okay, I think this is the last one. All right, so go ahead and push play, or excuse me, press pause and tell me what you know about it by just looking at it. Come up with the vertex and the axis of symmetry, make the table and graph it. All right, so I know some things just by looking at it. I know that 1/2 is a shrink, which means it's going to be wider than the parent function. I know it opens up because 1/2 is positive. I know H is going to be -4. And I know K is -2. There's K right there. So my vertex is -4, -2. My axis of symmetry is x equals -4. So -4, -2. I know it's opening up like a smile, and I know it's wider than the parent function. All right, so let's make our table. Up 1, -3, up another, -2, back 1, and back another. And we're just plotting in here into this x. So 1/2 times -3 plus 4, all squared, minus 2. I'm going to use my calculator. So 1ABC2 parenthesis, -3 plus 4 parenthesis, squared, minus 2. -1 and 1/2 for both of these. So -3, 1, 2, 3, -1 and 1/2 is right there. Same for -5. So let's put in 2 there, -2, and that pops out 0. -2, 0, something is wrong with this. And -6, 0, let's go back and look. 1, 2, 3, 4, 5, 6 right there. Okay, obviously something's wrong. It's not a parabola. It's a very strange shape. So let's look at -3 again. Stick -3 back in there. That still gives me -1 and 1/2, which is plotted correctly. Let me put -2 back in there. And that gives me 0. Something's wrong with it. Oh, it opens up. I don't think anything's wrong with it. It's just plotted wrong for the vertex. The vertex is plotted wrong. You probably knew that. 1, 2, 3, 4, down 2. There we go. There we go. That's better. Okay, I hope you can take a lesson from that, though. We were like, what is that? That is not a parabola. So we had to figure out what was going on. And I re-put them back in my calculator to see if these were right, and they were. So I knew it wasn't that. I knew the table was right. I re-looked at the vertex. I knew it was right. So then I thought, okay, maybe it's my plotting. And I figured out it was my vertex. I had my vertex plotted wrong. So hopefully if you get stuck and you get some W or some weird pentagon like we just got, you can go back and do those same steps that I just did. Okay, so domain is all real numbers. And range is y is greater than or equal because it's opening up. This is the lowest point on the graph right here, and that's -2, so that's a part of the range. Okay, I'm all finished. That last one was a doozy. All right, your assignment's on page 446, 447. You're doing the odds from 19 to 27, and then you're doing all of 32 through 44. So I'm assuming that the graphs are multiple choice since it's hard to graph in big ideas. Please do this online. It will take you much less time to do this online than it would on a piece of paper. So I hope you're having a good day and you had a nice weekend, and I hope Monday's treating you well. Have a good day. Bye-bye.